All right. So like I said, this is on how to make lithium ion battery packs and as a collaboration with Buckeye Solar Racing. Some contact info. So this is our general info. And if you want to reach out to any of the officers, they're also listed right over there. And our Discord server, you can click that link. It's really chill. Office hours, I believe Sid is hosting office hours every non-workshop Monday from 7 to 8. Is that right, Sid? What? I thought I saw him.
He was in the club room. He said he'd be up at minute.
Okay. Yep.
I think that's correct. Yeah.
Yeah. But if you want to reach out to him for different office hours, possibly, there's his email. And again, want to keep up the slides, go to our website. It's funny how it's linked here. And yeah, just type it in. Click slides and it should bring you to that. And for attendance, take attendance. This is for contact tracing. The university does want us to keep track of that. Also attendance for pizza. And e-council and yeah, all that stuff. And for our records. For those just walking in, this is a workshop on how to build lithium-ion battery packs. You can go to our website, electronicsclub.osu.edu to follow along with the slides and attendance. I'll leave this up for another minute or so, and then we can get right into it. Andrew, about that, I don't know how it works, but it just works with GitHub because our site's built on GitHub, and we just put in .osu and it just works. So I have no idea, man. I know the process to get a website like an OSU domain is a pain in the butt, though. But yeah. Alrighty, let's get to it. Oh, there's always more announcements. So I'm Edward, I'm the president, and we're looking for open officer positions, president in training, vice president in training, treasurer in training, and funding and sponsorship, or just a regular officer. A lot of us in the exec board are like upper class students, juniors, seniors, so we are looking for the next generation to lead the club on. All right, here's a caution. Basically, you don't have to read the whole thing. Just know that batteries are super dangerous, and yeah, it hurts. I can tell you from experience, it hurts. Let's see what else it says. In the case of battery leaks and fluid that gets on your skin, do that. Rub, rinse with water, yada, yada, yada. And here's some more warnings for more info. But yeah, I kind of pulled this from those sites. So these are really good sites to pull from. And yeah. Yeah, also always tend the battery. We had one incident when we're building the workshop where I'll talk about it later. So what are lithium ion batteries? So lithium ion, or Li-ion as some call it, are rechargeable batteries that primarily use lithium ions as its main component in its chemistry as per the name. It was prototyped in 1985 by Akira Yoshino and commercialized by Sony in 1991. So these are actually pretty old technologies because we're all like 2000s, so it's pretty old. They come in different form factors. So you have cylindrical right here. Looks like just a regular battery. These are 18650s. So basically, it's it's 18 millimeters one way and 65 millimeters the other way. Yeah, it's on a slide somewhere. Next, we have pouch type batteries. So these are more kind of ready to be used for any hobby electronics, as opposed to cylindrical ones, which need to be built. And we don't have the other one, prismatic batteries, but they look like that. So has anybody ever had like old Samsung Notes or an old Samsung phone? And when you rip the back off, there's a battery. That's the prismatic battery. Oh, I'm blind. Yep, so the most common standard for the cylindrical batteries is the 18650 format, 18 millimeters in diameter and 65 millimeters tall. And the second and third most common are the 21700s and the 26650s. So what are they used for? So they're widely used today to power any high density equipment. You see them laptops, phones, toys, and now electric cars like Tesla, Porsche, however they pronounce it. Unlike nickel cadmium and nickel metal hydride batteries, lithium ions don't have the memory effect when charging and discharging. So maybe a long time ago, your parents may have told you like, hey, like always charge this battery at first because it needs to have its memory kick in to know what's 100 and what's 0 and yada, yada, yada. Lithium ion does not have that issue. And as per battery density, so you can see lead acid, like the ones you have in your car, pretty bad density. Then you have the nickel cadmium, nickel metal hydride, then you have lithium ion. If I'm talking too fast, let me know so I can slow down. I talk fast a lot, so. Alrighty. So what makes up lithium ion batteries? So they're made up of an anode and cathode, which store the actual lithium in the batteries. A separator made of polyethylene or polypropylene. So like right here. Electrolytes made up of salts, solvents, or additives, and a positive and negative collector. And I had an animation somewhere, which is really cool. But yeah, so you have the anode, cathode. All this is filled with an electrolyte, a separator, so the ions can flow through back and forth through the battery. So how do they work? Here's the great gift. So during the discharge cycle, lithium ions move from the anode to the cathode and recombine with the electrons. During the charge cycle, lithium ions move from the cathode to the anode, which is reverse, of course. And then during both cycles, yeah, they move across electrolyte through the separator right here, which prevents the anode and cathode from making contact, because if that happens, then that's very bad. So nice Department of Energy animation. So that's the basics of how they work. So with great power comes great responsibility. So one of the most dangerous things with these batteries is thermal runaway. So that is an unstoppable chain reaction where the temperature and pressure of the battery rises rapidly and energy is quickly released violently. So I should have put that in Fahrenheit, but runaway begins at around 60 degrees Celsius and it's critical at 100 degrees Celsius. So what can cause runaway? So short circuiting inside the batteries, like when these two touch, the anode and cathode, internal or external. Yeah, we can talk about that later. Overcharging. So if you charge it and there's no circuitry protecting how much power you put into it, it can lead to just high resistance temperature and cause it to explode. Excessive current also with the overcharging, and misuse or improper use of the battery. So for example, here's a photo down here, pristine, good lithium ion cell, and that's after it blew up. And here's an animation, for example. So yeah, that's what you don't want. So you might have seen these every once in a while. We actually have a few down in the club room locked away in a box. So swollen batteries may come from overcharging, manufacturing defects, mishandling, or exposure to extreme temperatures, or just deterioration from aging. As a note for aging, at a certain point, the chemical reaction in the battery is no longer perfectly balanced, which leads to outgassing of the chemicals and resulting in a swollen battery as it blows up. And eventually this may lead to a fire. So if you have like a swollen battery, please get it checked out or get it replaced. After they get to this point, it's permanently damaged and should be disposed of properly and professionally. Here's a cute little video. Yep, that's an example. So you don't want to do that. Okay, how do we skip? There we go. Perfect. But don't worry though. When you build batteries, you can always take steps yourself to keep yourself safe or your device. You can buy batteries from brands like Samsung, Sony, Sanyo, LG, and Panasonic. These are like the top batteries. Actually, this battery I think is Samsung. Yeah, this is a Samsung battery. Invest in the battery safe box. So this was around $70, but pretty safe. When batteries explode, they release toxic, or I don't know, toxic, but bad fumes. And this actually filters out that fume, so it doesn't get all over the room and stuff, and all the soot that's trapped in here. That's also made of metal. If you want to go with something cheaper, just go to Walmart, buy an ammo can. Those are pretty thick pieces of metal, and they keep you safe. That's what I use at home, actually, for my batteries. A fire extinguisher or stand is great to have on standby. I think the regular ABC fire extinguishers are good enough for lithium ion fires. Don't quote me on that though. If you experience an event, don't breathe in the magic smoke because the magic smoke keeps all the electronics running. If you lose it, it doesn't work, but also don't breathe it in. Keep the batteries at room temperature and out of direct sunlight. Yeah, like you maybe put your phone in direct sunlight, you feel it heat up and stuff. Yeah, don't do that. If you notice anything fishy, err on the side of caution and don't throw it in the trash because you don't want any trash fires or anything happening in the future. Also, it's environmentally friendly to just recycle them too. And for the rest, use common sense. Follow the manufacturer's instructions and everything. Follow instructions that you're getting a guide from, and just don't be dumb with batteries. All right, so now to the juicy part: how to build a lithium-ion battery. So the materials you need is an 18650 battery, unprotected, and no top button. So some of these batteries have a little kind of top button, like a little like how AAA AA batteries are. Protected means that they have no circuitry to protect it, because you already buy a piece of circuitry that protects it when you charge and discharge. Actually, this is a piece of crap, by the way, I tell you. But that's what you need. Battery holders. So, I'll show you guys. Really cool things. So, like battery holders. Looks like this. You can piece it together to make however big of batteries you want. Like you find these on Amazon, they're pretty cheap too. Just pieces of plastic, or you can 3D print them with their 3D printing service. A battery management system. So that's what this is. And a little disclosure: don't get these from Amazon. Get it from a good site because bad things happen if you get cheap things like this. Nickel strips. So there's two options. You can get pure nickel, which is expensive, or you could get nickel plated steel. Both work, but nickel, like plated, pure nickel is actually better at thermal management. But here's an example of the nickel plated or steel plated nickel plated steel. Yes. And if you see any listing that says pure nickel and it's really cheap, don't trust it. Next, you need a switch, depending on how much amps you're using through the battery. So this one is good for, I think, 20 amps. So this is a switch that we use. Next is a suitable connector of choice. Now, people online use like DC barrel jack and stuff. We use XT90 connectors because we never had XT60 connectors in the club room. So these are just bigger and beefier. So this is our connector of choice. But you can do barrel jacks or just banana plugs, anything that works with the amount of current you're putting through it so it doesn't melt. All right, and for equipment wise, you need a spot welder. So this is what this puppy is right here. This bonds the nickel strips to the battery, so you have a sound connection. A soldering station, so you can solder the bus bars or the little nickel strips to the BMS. A multimeter, just because you can see the voltage of the batteries and how you're doing. A lithium-ion charger. So if you are using like already used batteries you salvage from a laptop, having a lithium-ion cell charger is really useful because when you put these batteries together, you want to have them at the same exact, not same exact, but very similar voltages. So there's no events that go on. And wire cutters or wire strippers, safety goggles, and a hot air gun, and a hot glue gun, so you can glue this onto your battery pack. Obviously, we don't have the funds to have everyone build a battery right now, but yes.
Do you mean like for the lithium ion charger, are you saying that you should charge them all up so they're all at the same level
Yeah.
when you put them together, before you put them together?
Yeah, because some
Okay.
batteries might be like discharged, so we
Right.
want to charge them up. For example, these ones come at 3.7 volts, and that's the maximum it can hold. So it just makes everything more balanced when you put it together, so nothing happens. Disclaimer about safety: don't touch the contacts. I'll tell you about my story. So when I was putting this together, these two contacts, I can't read the labels, but I was cutting a bus bar and I dropped the wire onto them and I burned myself. Like it gets hot real quick. Hotter than the sun, I think. I don't know, but I know it hurts. I didn't get shocked, I think, but you don't want to get shocked with that because, yeah, things can kill you. So how do you build a lithium ion battery pack? So first you got to figure out what you want for your use, for your purpose. For my demo, I wanted something around 11.1 volts and around 18 amp hours. Note, if you want more voltage, add more in series. If you want more amp hours, add more in current, or add more in parallel, sorry. Here's a nice tool that you can use. Basically, so the convention I use is S and P, so series then parallel. So you can mess around with this and find what you want. So 3.7. Don't care about this much. I'll leave it as is. So I want, for example, I want 11 volts. So let's see what I can get here. 3 in series, and I want around 18 amp hours. This is 10, so just go up, and then what's that? I'm doing the math right. Oh, yes, cell capacity. So I think these are 3 amp hours each. So 3, or is it 3.5? Yeah, it was 3.5. I can show you some sites I can use, but yeah, these are 3.5 amp hours each cell. And then doing the math, this is just a calculator, 11.1 volts and 18 amp hours, which is what I want. And all the other stuff isn't that relevant, but you can still read it if you would like. Let me get back to full screen. Yes. Yep, I had it down here. So it looks like we need 3 in series, 5 in parallel, or 3S 5P. Here's the hard math if you're interested. So yeah, I have it here. 3.5 amp hours per battery for 8 amp batteries. And if you do the math, so this is in milliamp hours, take the total milliamp hours and divide it by that. That should be 18. Sorry about that. But here's the hard math here if you're interested. And notes that there's not much difference between 3.6 and 3.7 per cell. Manufacturers just mark it up 0.1 volts, 3.7, just because it looks better on paper. But we're using 3.7. So the first thing you have to do is throw together your battery holders. So I put these in a 3x5 configuration, and you need 2 of them because you need one for the top and for the bottom. When you put the batteries inside for this configuration, make sure the parallel sides, like the ends here, this is I have it positive up, in the middle is negative up. And again, I'll reiterate, it's recommended to use new batteries where the cell voltage is around 3.5 to 3.7 volts. If you're using older reclaimed batteries, make sure to charge it in a lithium ion battery cell charger. And just because I was curious, I just measured all of the batteries beforehand, and it was ranging between like 3.5 and 3.7. So, and this is what it should look like with the final setup. So 2 positive rows and 1 negative row. And if you flip it upside down, it should be the opposite. So cutting nickel strips for bus bars. I said this already. Pure nickel strips are better for thermal management than nickel plated steel, but they're costlier. So what you have to do is cut 4 long nickel strips, enough to span the 5 cells, with a little extra room for their BMS connection, and then cut 10 short strips for spanning 3 cells. I got this in a tape. In that, you rip the tape off. Yeah. Yeah, we taped it up so no metal would contact any other metal, and bad things would happen if that happened. Now, time to weld. So the reason we want to spot weld is because opposed to soldering, because when you solder, the material gets really hot, and that is really bad for the batteries. So we want to keep it as cool as possible. So when we want to have a lot of heat in the shortest amount of time, and that's where spot welding comes in. Too much heat can mess with the battery's chemical reaction and chemical electrochemistry, as they call it, and cause damage to the battery's performance. On this one, or on all of them for that matter, there's 2 settings. There is the pulse and current. So current is how much current you want to put through. And pulse, I have it set for 2P. So you can do 1 pulse or 2 pulses. I did 2 pulses because the first pulse cleans the surface, and the second pulse actually welds the batteries together. And yep, we got this from Amazon. Works pretty well. We have links for all these later in the slide deck. Yep, current is the amount of electricity going through the pulse, and the pulse duration, but the pulse is the duration of the weld. So, yep. This is a bad weld, by the way. A good weld, I recommend that you try to have test welds first to find your optimal setting. That's a bad weld. You don't really want that. But a lot of batteries just have 2 sets of spot welds per battery pack. So it's like 4 little dots you'll see. So wiring the BMS is pretty simple for this iteration. So this is a 3S BMS. And I found this diagram with the manufacturer's instructions. Because you don't really touch these cells much, it's okay to solder this part. You're just touching these pads really. And the rest of the heat will dissipate by the time it gets to the, goes to the bus wire and gets to the batteries. So for the on and off switch and the connector of choice, this is what I have my like really bad wiring diagram set up. So for the input output, I have the connector bypass everything, but I have the battery level indicator on a switch. I don't want to talk about the battery level indicator. Yep, this is the battery level indicator. It just tells you how much power you have left in your battery. Yep, and I lied. We don't have an XC90, not XC60. And then we link those back to right here. So protection. So we recommend like 3D printing a case or purchasing a case. You can 3D print up ABS, provides extra protection to the battery pack from any external forces. The battery cell holders protect it pretty well from vibration and stuff. You can also shrink wrap it like on this one in this photo. That's what we attempt to do with that. You can forgo these, but we do strongly recommend you protect at least the terminals and the bus bars of the battery. And again, plugging our 3D printing site if you would like to use that. Thermal management. So thermal management, actually, I was doing this for the solar cartoon. Very primitive technology right now, apparently. It's pretty hard to find thermal management. And there's been a lot of studies on what's the most optimal way. And here's what I found after reading a few studies. So to keep things relatively cool, the BMS does a decently good job at keeping everything cold. The battery should stay around 20 to 30 degrees Celsius. Again, that I think 50 or 60 to 100 is the critical range of thermal runaway. For more thermal management, ways to go is liquid cooling, to similar how a car cools its engines, pumping oil through the engine. So what you could do is pump oil, water or your liquid of choice through the sides between the battery cells. But I saw that it's really optimal because most of the heat stands with the bus bars. So cooling that will be effective in keeping your battery cold. For something less costly and kind of also a lighter weight too, air cooling is also an option to have. And a lot of cooling systems have thermal resistors on different parts of the battery packs, like on cells, on bus bars, just to tell a computer and monitor the temperature, like, hey, this is getting hot and stuff. Yeah, and then cooling the nickel tabs is great too. Here are some resources that we bought from. Don't buy this. This is really bad. Everything else is pretty good that we recommend. Battery holders, a switch, battery level indicator, a spot welder, battery charger, safe box, and all that stuff. And here's a nice wiki on Reddit and how it has a lot of resources additional to this presentation, how to make a battery pack. So if you want to try spot welding, you can always come up and give it a try. It's all set up. So